Let's say that I have the point 2, 3, and another point, it might be 6, 7. Okay, so let's see what they look like on our Cartesian plane here. So 2, 3 would sit here, and 6, 7 would sit up here. Now, what we're going to be looking for is what we call the midpoint, okay? And that is the point that sits exactly halfway between those 2 points. So if we connect these 2 points with a line, like so, then the midpoint is going to be exactly halfway along that line. Now, in this case, we could count how many diagonals of a square we go along. So, for example, that's 1, 2, 3, 4 diagonals of the square. So if we want the midpoint, we've just got to do half of that. So only 2 diagonals across the square. So we would go 1, 2. So our midpoint would sit here. And we can read that coordinate straight off the page as 4, 5. So we know that the midpoint of these 2 points here would be the point 4, 5. But that kind of method might start to fall apart as we get some trickier points, which don't go so nicely through our diagonals of our squares. So what's another way that we can think of this? Well, instead of following our path from point 1 to point 2 on a strict straight line, let's break it into 2 components. Let's first look at a horizontal component, and then we'll look at a vertical component. So instead of going straight there along the hypotenuse of this triangle, let's follow a different path. Let's go horizontally first, and then we'll come up. And we'll go vertically. So if we look at how far we've gone horizontally, we've gone 1, 2, 3, 4 units along the bottom here, horizontally. And vertically, we've then turned around and we've gone 4 units upwards. So to go from point 1 over to point 2, we've gone 4 to the right and 4 up. So if we want to do exactly half of that, well, let's only go 2 to the right, and then let's go 2 up. So we'll see what that looks like. So if I go 2 to the right instead, I go 1, 2, and then I go 2 up. I go 1, 2 here. Okay, so I end up at that same point, 4, 5. And I can look at that of these 2 points. I can look at 2 and 6, and I can go, okay, well, how far have I gone horizontally here? I've gone 4 horizontally. How far have I gone vertically? I've gone plus 4 vertically. So if I want to do half of that, I need to do 2 more in my horizontal component, and then I need to take my 3 and add 2 to that, and I get the point 4, 5. So that's what we're talking about when we look at midpoints. Let's look at another example now, and we'll go through it all again. So for this one, let's look at the points 1, 1, and we'll take the point 4, 3. Okay, so we've got our point 1, 1 here, and our 4, 3 sits there like that. Now, if I connected a straight line across these 2 points, it's kind of tricky to see exactly where halfway would be. Okay, and they can start to get a little bit complicated, especially as these points get further apart and we're not following, say, straight across the diagonals of these squares. Okay, so as they get further apart, it can get a little trickier. So what do? Well, we take that concept which we just spoke about, looking at a horizontal component and then a vertical component. So instead of going from point 1 to 2 across my black line there, let's go a horizontal distance, which would be 3, and then a vertical distance, which would be 2. Okay, and we see that here, going from 1 to 4, we've gone 3 to the right, and 1 to 3, we've gone 2 up. So we're looking at 3 to the right here and 2 up. So how can we go halfway now? Well, instead of going 3 to the right, let's only go 1.5 to the right. And instead of going 2 up, let's only go 1 up. So we're going to do exactly half of our previous movements. And what does that look like? Well, I go 1.5 to here, and then I go a full 1 up. And we end up at that point there. And that would be the point 2.5, 2. Okay, and we can see that if I take this point here, my 1, 1, and I go 1.5 to the right, then my x coordinate is now going to be 1 plus 1.5, and my y coordinate will be the 1 plus the 1 unit that I move up. So that would be 2.5, 2. So hopefully that concept of the midpoint is starting to make some more sense. We'll take a look at another example now. So we'll come down here. This time we're going to introduce a little bit of a formula. So what we say is that if let's say that I'm looking for the midpoint of these 2 points here, that point, and we'll take the point 31, 19. So let's say that I'm looking for the midpoint here. We can come up with a little bit of a formula. The midpoint is equal to, we take our first x coordinate and our second x coordinate, and we divide it by 2. We take the average of those x coordinates. So that kind of gives us that halfway in our horizontal direction. And then we take the average of our y coordinate. So we kind of get that halfway distance in our vertical direction. So that's kind of what we spoke about before. And I don't really like to introduce formulas without kind of giving you a little bit of background at where they come from. So this is just us taking that average horizontal distance and the average vertical distance. So let's see it in action. Well, in this case, this coordinate here would be my x1, this one here would be my y1, this one here would be my x2, and this one here would be my y2. So let's start off by comparing the horizontal components. So let's look for exactly halfway between the horizontal components. And we do that by adding them together and halving them. We kind of take an average. And then we'll look at halfway between our vertical components. So hopefully you've got a little bit of a visual from before at what it is that we're doing now and why this is going to work. 15 and 19, and we'll half that. Okay, so if we simplify these down, we get 38 over 2 here, and we get 34 over 2 here, which gives us the point 19, 17. Okay, and you should be able to see that halfway between 7 and 31 would be 19, and halfway between 15 and 19 would be 17. Okay, and that's what we're doing when we're plotting for the midpoint. So that is going to be, that would be our midpoint for these 2 points here. We'll do one more example using this formula, and we'll start to introduce some negative coordinates, okay, just to cover all bases. So let's take a look at the point -3, 6, and we'll take the next point -13, 8. Okay, and remember our midpoint, what we're doing is we take the average of our horizontal component or our x coordinates, and we take the average of our y coordinates here. So if we do that, our x1 would be -3 and our x2 would be -13. Okay, and we're going to divide that by 2. And then our y1 would be our 6 and our y2 would be our 8, and we're going to divide that by 2. So let's simplify these down. -3, and I'm adding a negative, so we're going even more negative out to -16 now. And I've got my 14 over 2 here. So my midpoint would be -8, 7. Okay, so that is halfway between these 2 points here. And you can kind of see that because, again, halfway between -3 and all the way to -13, halfway between those would be -8, and halfway between 6 and 8 is clearly going to be 7. Okay, so hopefully that gives you a little bit of an appreciation for visually what's going on when we're solving for the midpoints, and then here algebraically how we can understand this formula and use it to tackle some trickier questions.